4.1, solving systems of linear equations in two variables. So, a system of linear equations. A system of equations consists of two or more equations. The solution of a system of two equations in two variables is an ordered pair, x and y, that make both equations true. Determining whether an ordered pair is a solution, plug x and y into both equations. If they both produce a true statement, then the ordered pair is a solution. So let's determine whether negative 3, 1 is the solution of the system. Let's determine whether negative 3, 1 is a solution of the system. So we have x, we have y. We need to plug them into both equations. So we're going to plug it into x minus y equals negative 4, and then we're going to plug it into 2x plus 10y equals 4. So a system is denoted, meaning shown, with this little thing right here. Now it's called a brace. They're not related to parentheses or brackets at all. They're called braces. I don't know why. I don't know why they're called braces. How do you draw one? Well, I suck at it. But one of my students a couple semesters ago told me, draw a bird but sideways. You know the stick figure birds? This is so hard for me. That's not bad. You know the stick figure birds you draw? Just draw it sideways, and that's a brace. Anyways, and then I never looked back, so I'm trying to practice it that way. All right, let's plug in our x and y. So we have x, which is negative 3, minus y, which is 1, equals negative 4. So negative 4 does equal negative 4. Cool, it works for the first one, but we have to try both. So we have 2 times x, which is negative 3, plus 10y, which is positive 1, and that equals 4. So we have negative 6 plus 10 equals 4. 4 does equal 4. So since they both work, this is a solution. That's actually where they cross. So if we were to graph these two equations, they would cross perfectly at negative 3, 1. Every time you find an x and a y, you're finding a solution or the solution. It just depends if it's a system or not. So we can solve systems 3 ways: graph, substitution method, and elimination method. So let's solve a system by graphing. Since the solution of a system of two equations is a solution common to both equations, it is also a point common to the graph of both equations. To find the solution of a system of two linear equations, we graph the equations and see where the lines intersect. Now, graphing systems is more of a I want to see generally the answer, because you're going to see sometimes they don't land perfectly on top of each other where you can read it. And you'll see that between example 2 and 3 and what I mean. All right, so can we switch the 10? Let's switch that to a 9. Switch that to a 9. It just works better. All right. So what we do, if it's a system of equations, we just separate them. A system means we're working with two or more equations. That's all. So we just work with them separately. So I'm going to separate them completely. Because when we separate them, it just looks like we're doing part A and part B. So we're just graphing both of these equations on the same plane. So to graph it, remember it needs to be in y equals mx plus b. So the first thing I'm going to do is subtract 2x. And when I do, we're left with negative y equals negative 2x plus 6, divide by negative 1. So we have y equals, wrong color, y equals 2x minus 6. So that means we have our slope and y-intercept. So our slope is 2 over 1. So we can go up 2 and right 1, or we can go down 2 and left 1. And then our y-intercept is 0, negative 6. All right, we'll graph it in a second. All right, now let's find the same information for the second equation. So the first thing we're going to do is subtract x. And when we do, we have 3y equals negative x plus 9. Divide by 3. And when we do, we are left with y equals negative 1/3 x plus 3. So our m is negative 1/3, meaning we can go down 1, right 3, or we can go up 1, left 3. Our y-intercept is 0, 3. If you struggle with graphing lines still, and you're like, I just need more practice, I need to get more confident in that, go back to 3.5 or 3.3 to 3.7, and then that's a lot of graphing practice. So go back and review it, then come back to this video. All right, let's graph each of these. So for our green one, we have 0, negative 6 is our start. And then we're going to use our slope. So I'm going to go up to right 1, up to right 1, up to right 1. When you're trying to find 2 points that match up or 2 lines that cross, you want a lot of points. So put as many as you can. So put as many as the graph will allow you to. So I'm going to go up to right 1 until I can't anymore. All right, then I'm going to go back to the start and go down to left 1 until I can't anymore. All right, from there, that's when we connect the dots. So you want as many points as possible because we want to see where they're going to cross. All right, now our purple one, we have a start of 0, 3. And now I need it to cross the green graph. So I need to go this way to cross it, right? So I'm going to go down 1, right 3, down 1, right 3, and they do cross. But you see how they don't match up perfectly, like point on point? So that's hard to see. It is. You can't figure out that answer because it's somewhere right here. It's a decimal. You cannot perfectly find that answer. That's why graphing is more of an approximate, where is the solution? There are times where it comes out perfectly, and the next one will be. So I'll actually give you where they cross. They cross at 3.9, 1.7. And that's true, right? Isn't it right about 4, and then it's just under 2? So we graphed it pretty well. All right, now let's, if you are unsure of the point, check the solution. Neatly drawn graphs can help when guessing the solution of a system of linear equations by graphing. So if you're unsure, plug it back in. And be neat, use coordinate planes. All right, example 3. We're going to switch this. I want to make it something just better for us, something I like more. So we have y equals 3x minus 4, and then we have y equals negative 1/2 x plus 3. So the first thing we're going to do is separate them. So we have our first one of 3x minus 4. We have our second one of negative 1/2 x plus 3. Now what I want you to do is pause this video and try it on your own. You will get a perfect answer. So go ahead, pause it, try it. I really hope you did it. So first things first, let's find our slope. It's 3, so 3 over 1. That means we can go up 3, right 1, or we can go down 3, left 1. Our y-intercept is 0, negative 4. Now for our purple one, our slope is negative 1/2. We can go down 1, right 2, or we can go up 1, left 2. And then our y-intercept is 0, 3. So what we're going to do is graph both of these. So for our green one, we have 0, negative 4 as our first point, and we want a lot of points. So I'm going to go up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1, and then down 3, left 1, down 3, left 1. We're going to connect the dots as best as we can. As best as we can. There we go. That's good for me. All right, now we move on to our purple one. So our start, our y-intercept is 0, 3. And then to get to the graph, I need to go down. I need to go to the right. So I'm going to go down 1, right 2. That's it. You see where they cross? You see how they perfectly crossed each other? They're on top of each other, but dot on dot. So when you have dot on dot, just stop. You're done. That's your answer. And it perfectly, perfectly, perfectly crossed at 2, 2. Now, if you're unsure, you can always plug it back in, but you'll get the right. It will work. What is I'm trying to say? All right, identify special systems of linear equations. There are 3 possible outcomes when graphing 2 linear equations in a plane. 1 point of intersection, that's 1 solution. Parallel lines, no solution. The same line, infinite number of solutions. If there is at least 1 solution, the system is considered to be consistent. If the system defines distinct lines, the equations are independent, meaning if there's no solution. So this is what it looks like. 1 solution, they cross perfectly. That's consistent, it's independent. No solution is inconsistent, and it's independent. And infinite is, it's consistent because it's all the same thing, but it's dependent. All right, another way to solve systems is substitution, which is the most used way. So get comfortable with it. It's the way you're going to use in trig, pre-calc, college algebra. You use substitution so much. It's such an ideal concept to really get down. All right, solving a system by substitution. The first step is to solve for a variable in one equation, meaning get a letter by itself in one of the equations. Put the new expression into the equation that has not been worked with, meaning whatever you get in step 1, put that inside the other equation that you haven't messed with, that you haven't touched, that hasn't been worked with. Solve. Plug whatever you solve, plug into any equation, and find the remaining variable, any given equation. All right, so our first step is to solve for one variable in an equation. So first, look, do you have that? Do you have y equals or x equals? We do. We actually do have that. It states x equals y plus 4. So that was step 1. Step 2 is to plug it into the equation we're not working with. The top equation we did nothing with. And this is saying x is y plus 4. So we're going to plug it in as x. So we have 2 times x, which is y plus 4, plus 3y equals 13. So we're going to solve now. Step 3. Distribute. We have 2y plus 8 plus 3y equals 13. Combine like terms. So 5y plus 8 equals 13. Subtract 8 to both sides. So we have 5y equals 5. So y equals 1. Do you notice when we plugged in y plus 4, we only had one variable now? We only have y. There's no x and y, it's just y, because that's the goal. That's what we're trying to do. Now that we found y equals 1, we need to plug it back into any given equation. So I'm going to plug it into the one that looks easiest. The one that looks easiest to me is x equals y plus 4. So we have x equals 1 plus 4. So 5. That means we have our point, we have our answer of 5, 1. So if we were to graph it, that's actually where they cross. All right, next example, we have x minus y equals 1 over 2x plus 2y equals 4. So first thing, look to see if we have x equals or y equals. We don't. We don't have that. So we need to get an equation and that looks easiest. So to me, the top one looks easiest. Now we need to solve for a variable, meaning get a letter by itself. I'm going to get x by itself. So we have x equals y plus 1. Now that I have x by itself, I'm going to plug it into the equation we didn't touch. We did nothing with the bottom, so I'm going to plug it in as x. So we have 2 times x, which is y plus 1, plus 2y equals 4. Now we solve. So distribute the 2. We have 2y plus 2 plus 2y equals 4. Combine like terms. And when we do, we get 4y plus 2 equals 4. Subtract 2. So 4y equals 2. Divide by 4. And we get y equals 1/2. So that's what y is. Y equals 1/2. Now we need to plug it in to a given equation. Now if we look at the given equations, x minus y equals 1 and 2x plus 2y equals 4, I'm going to plug it into the bottom one. It looks harder, but with fractions, you see how we have a 2 and a 2? That's why I'm plugging it in, because you're going to see what's going to happen when we do that. So we have 2x plus 2y equals 4, and y is 1/2. So we keep simplifying. We have 2x plus 2 over 2 equals 4. We know 2 over 2 is just 1. You see how it got rid of that fraction? We're going to subtract 1 to both sides. So we have 2x equals 3. Divide by 2. We get x equals 3 over 2. So see, if we were to graph that, we wouldn't be able to figure that out. Unless it's like a perfect graph on a calculator. But anything drawn by hand, you never know. You'd have to check it. But with this, you don't have to check. These are the answers. So we have our solution of 3 over 2, 1/2. Yep, we keep it as a fraction. Why? Because fractions are exact. All right, another way to solve a system is by elimination. It's also called addition method. So another method that can be used to solve a system is called elimination or addition method. Rewrite each equation in standard form, which is ax plus by equals c. Make one of the variables have the same coefficient number in front, but opposite sides. Multiply one or both equations to achieve this. Add the equations, solve for the variable, plug the found value in step 4 into any given equation, and be sure to check if you're unsure. I know, that sounds a lot harder than it is, but it's actually, it flows nicely. All right, example 5. So we're starting off with fractions. If we have an equal sign, do we have to work with fractions? Nope, we don't. We do not have to work with fractions here, so let's get rid of them. If we don't have to work with them, why do it? Let's get rid of them. All right, so I'm going to separate them so we can get rid of the fractions. So we have 2/3 x plus 1/4 y equals negative 3 over 2. And then we have 1/2 x minus 1/4 y equals negative 2. So let's get rid of our fractions. So for our green one, we would multiply everything by 12 over 1. So we have 12 over 1 times 2/3 x plus 12 over 1 times 1/4 y equals 12 over 1 times negative 3 over 2. So let's go ahead and simplify our fractions. So 12 divided by 3, we're left with 4. 12 divided by 4, we're left with 3. And 12 divided by 2, we're left with 6. So we have 4 times 2x is 8x, plus 3 times 1y is 3y, equals 6 times negative 3 is negative 18. So that's our new equation we're going to work with. 8x plus 3y equals negative 18. Much easier to work with. Now, same thing for our purple one. So we're going to multiply everything by 4 over 1. So we'll have 4 over 1 times 1/2 x minus 4 over 1 times 1/4 y. Times 1/4 y. And that equals 4 times negative 2. It's not a fraction, so we don't need the fraction. All right, let's go ahead and simplify what we have left over. So 4 divided by 2 is 2. 4 divided by 4 is 1. And 4 times negative 2, we'll get to that. So 2 times 1x is 2x minus 1 times 1y is y equals 4 times negative 2, which is negative 8. So that's our new equation we're going to work with, which is 2x minus y equals negative 8. All right, so I'm going to rewrite them now top and bottom. So I'm going to just rewrite them where we have some space. So we have 8x plus 3y equals negative 18. That was the green one. And then our purple one, we have 2x minus y equals negative 8. Okay, so now we're going to work with this. Now we're going to do elimination method. So we want to look at both equations, and we're going to look at it as one. So we put a little bar and we put a plus sign, because that's what we're doing. We're going to add our columns. Columns are up and down. All right, so let's look at a variable that have opposite signs, if there is one. We do. Y's have opposite signs. So since that's the case, I need them to be same number, same letter, opposite sign. So to make them have the same number, same letter, but opposite sign, I need to multiply the bottom by 3. So on top we have 8x plus 3y equals negative 18. And on bottom we have 3 times 2x is 6x, 3 times negative y is negative 3y, and 3 times negative 8 is negative 24. And now we add the columns. So 8x plus 6x, we get 14x. Positive 3y minus 3y, they cancel. That was the goal, was to get rid of them. Negative 18 minus 24, we get negative 42. Now we solve. So divide by 14, and we get x equals negative 3. So now we have to plug it back in. We can plug it back into one of these. We can plug it back into one of those. So I'm going to plug it back into the bottom one. So 2x minus y equals negative 8. So 2 times x, which is negative 3, minus y equals negative 8. So 2 times negative 3 is negative 6 minus y equals negative 8. Add 6 over. We have negative y equals negative 2. Divide by negative 1. So we get y equals 2. That means our solution is negative 3, 2. Remember, that's the point. So if we were to graph them, they would cross exactly at negative 3, 2. All right, no fractions for the rest of them. That was it for that. But I just wanted to show you we don't ever have to work with them. If there's an equal sign, get rid of them. All right, so next example. Let's look to see if any of our variables have opposite signs. They do. X and y have opposite signs. So pick a variable to get rid of. I'm going to get rid of x. Why? Because I want to. I just want to get rid of x. So to get rid of x, they need to have the same number, same variable, but opposite sign. So to get that, I need to multiply the top by positive 3. So we multiply, we have 3 times x is 3x. 3 times negative 3y is negative 9y. 3 times negative 2 is negative 6. And on the bottom, we did nothing. And now we add our columns. So 3x minus 3x, that cancels. Negative 9y plus 9y, that cancels. Everything to cancel, we have 0 equals negative 1. Does 0 equal negative 1? No, that's not true. That's not a true statement. That's never going to be true. 0 does not equal negative 1. So this is no solution. Meaning, if you were to graph them, they would never cross. Ever. So that's what we just found. They never cross. Crazy, right? So I'm going to show you how to find no solution also using substitution method. So remember, this was elimination method. So just for the notes and just for the sake of more examples, let's talk about substitution method with no solution. Because it's a little weird and I want to make sure that we get this. Alright, so the substitution method, I'm going to rewrite our system. The system. So I need to get one variable by itself. So I'm going to look at the top equation and take it out. We have x minus 3y equals negative 2. The easiest thing to get by itself is x. So I'm going to add 3y to both sides. So we have x equals 3y minus 2. So in the equation we didn't work with, I'm going to plug it in as x. We have negative 3 times x, which is positive 3y, minus 2, all plus 9y equals 5. So let's distribute. We have negative 9y minus 2 equals 9y equals 5. Plus 9y equals 5. We combine like terms, and do you see when we combine like terms, we have negative 9y and positive 9y? They cancel, so we have negative 2 equals 5. That's not true. Since that is not true, it's no solution. They both, let's look to see if variables have opposite signs, and x and y both have opposite signs. So it's really up to you what you want to get rid of. Let's get rid of y for this one. No particular reason. We did x last time, so let's get rid of y. All right, so to get them to be the same, we need to have same variable, opposite signs, and same number. So I need to multiply the top by 2. So I do that. I have 4x plus 10y equals 2. And on the bottom, we have negative 4x minus 10y equals negative 2. So negative 4x and negative 4x cancels. Positive 10y, negative 10y, that cancels. 2, negative 2, that cancels. That means we have 0 equals 0. Now that's a true statement. 0 does equal 0. That means this is an infinite solution. Meaning it's the same line. So if you graphed it, they just graph on top of each other. So it's infinite solutions, or we can say negative infinity to positive infinity, or you can say all real numbers. If there's a substitution method, everything would cancel out just like it did here. That's why I'm not showing you. All right, let's do the next example. We're going to start the next example, and then you will finish it. All right, so we have 4x equals 14y minus 5y, 3x minus 2y equals negative 1. We have to get it into standard form. So to get it into standard form, it needs to be x, y equals. So I need to move this over. So we have 4x plus 5y equals 14, because the opposite of negative is positive. And then the bottom one is in standard form, so we're good to go. Now we look for signs that are opposite. The y's have opposite signs. So the y's need to be the same number, but opposite signs, same variable. So the same number they have in common is 10. So I can make them both 10. So the top, I need to multiply by 2, and the bottom, I need to multiply by 5 in order to be 10. So on top, we have to distribute. So we have 8x plus 10y equals 28. And on the bottom, we distribute. So we have 15. So on the bottom we distribute. We have 15x minus 10y equals negative 5. Let's add our columns. So 8x and 15x is 23x. 10y minus 10y is nothing. And that equals 23. So we divide by 23. We get x is 1. Now we have to plug that back in to solve for x. You can plug it into any of them. I'm going to plug it into 4x equals 14 minus 5y. So we have 4 times 1 equals 14 minus 5y. So 4 equals 14 minus 5y. Subtract 14. So we have negative 10 equals 5y, negative 5y. Divide by negative 5. So we get 2 equals y. So our point is 1, 2.